Good morning, everybody. Welcome to one more episode of Chats. I know we skipped a few weeks. We were busy with some of the material launches and some of the new product updates that we have coming for you guys. But yeah, it's going to be a good one as always. So welcome. My name is Felipe, Creative Director here at MakerBot. And today, it's going to be very straightforward, but also I think really interesting. As you can see, I got a different setup. Basically, the main webcam here, a secondary camera here pointed at the extruders. And the reason for that, and I'll toggle between both of them right now, but the reason for that is we've been getting a lot of questions on, okay, how does it actually work printing metal? How easy it is? What are the steps? And I'm going to be covering one of them right now. Essentially, I'll run a print throughout the whole chat's duration, and I'll open the floor for questions if you have any. Otherwise, I'll be talking about a few of the things to consider when printing metals, kind of the process, general questions that we've heard. And yeah, with that, I'll just confirm that things are looking good on your guys' end. By the way, Alejandra is also grabbing questions for us in the back end. So if you have any, just type them on that chat box to the top right of your screen, and she'll be forwarding those questions to me. So I'll go ahead and jump right in because it's going to be, we only have about 30 minutes, meaning it's a fairly short amount of time to print. So I'm here now on CloudPrint. If you guys haven't tried it, that's our cloud-based slicing solution. It's much better. Well, not better. It's like as good, if not better, than our standard MakerBot print for desktop. However, it's cloud-based, and it allows you to control multiple printers at once. It allows you to control multiple queues of those printers. And in this case, I already have my print here queued up in this printer, which is I named XBot, which is the one that's right beside me. I'll go ahead and click Start. I'll start this print and then I'll queue a second one just so you guys can see kind of the process of selecting the metal material from CloudPrint and how easy it is. The reason why I want to get it started is because it's going to be about 20 minutes of print time. So yeah, we want to sort of be sure that we have enough time to get everything started. So here it is, starting on my printer. I have also an additional lens that might come in handy sort of for those macro shots. I'll be playing with it. Where is it? Here it is. Which should allow us to better focus on the printer and on the extruders as they print. Right now, I'll be moving the camera a little bit, so I apologize for any motion sickness that this might cause. Let's see, did we use the macro lens or I don't think we need the macro lens for now. Sorry about the reflections. Those are the lights in my apartment. We are still working from home over here in New York City. But in any case, what's happening now, it's the heating process is taking place, right? Essentially, the printer is heating up to 60 degrees Celsius. That's the whole printer, the whole chamber, not only the build plate. As we've discussed in the past, Method comes with not just a build plate or a heated build plate like many of those desktop printer systems, but rather a full-on enclosed chamber that heats up to the desired temperature. In this case, 60 degrees Celsius for metals, about 100 degrees for ABS and other thermoplastics. All right, so I'll let it run. Just, maybe following the process here. Right now, the chamber is at 42 degrees Celsius. It should get to 59. It'll take a few minutes. And in the meantime, as I promised, I'm going to take you guys back here to CloudPrint and show you the process that I took to slice these parts. So essentially, in CloudPrint, you can see all of your printers, right? What I'm going to do is just hit start a new print here on the one printer that I want to use, the XBot that I mentioned before. It'll ask me to select a file from my computer, right? So I'll just navigate to that file. I have this one right here called S-Hook Metal, pretty standard naming convention there. Yeah. It places my part on my build plate, right? Same functionality as before. You can orbit the build plate, you can move the part about. And here, under extruders and materials, it already has preloaded the extruders that it's detected on my printer, right? So it knows that I have a labs extruder loaded, and it knows that I have a support to XA extruder loaded. However, since it's a lapse extruder and I have the ability to override any material settings, I'm going to go ahead and hit metal from this drop down, right? So you can see, I'll do that once again. Here, extruders and materials, you see slot 1 and slot 2 referring to the extruders. On my lapse extruder, I can actually go ahead and click metal, right? And that's it. It's nothing like too crazy, right? It's fairly straightforward. I can just hit Q. That will slice it in the cloud, so it's not taking any local resources from my computer. It's that straightforward. Even if I'm already printing, the cool thing about MakerBot Cloud, like what's happening here, I'll jump back to my dual view here of the printer, heating up. There's just so you guys can see, there's nothing happening just yet. But the cool thing about Cloud Print is that I can, as you can see now, a new job appeared here underneath my list of, underneath my printer tile, right? So I can add as many jobs as I want, and it's going to essentially be populating that queue. As the queue finishes up, I can select to start the next print over, and yeah, it's that simple. I mean, the software just takes care of all of the settings for you. In case you were wondering, because I've heard that question a lot, what are the temperatures that we've been using for the 316L BASF metal material? That's 60 degrees for the chamber, 245 degrees Celsius for the extruder, and there's a few settings that also change on the back end, meaning the retraction rate, the speed, the infill settings. Many of them are available out there. You can look at them, but I would highly recommend to just go into Cloud Print, and as you saw, just select that drop down, and you're ready to go. So even though I'm already printing one, it has all of my queued up jobs here, right? So I have another one, and I can add as many as I wish. So for now, I'll let it run. I'm going to jump back here to my camera view. Let's see if I can bring you guys a little bit closer. Hoping that as soon as the print starts. So right now, the chamber, it's at 56 degrees Celsius, about 4 degrees missing until it starts. And the print time overall is going to be about 20 minutes, right? I'm going to just let it run, and I'm going to be looking at the questions in the meantime, just because that's kind of the point, right? We've been getting a lot of questions around, how does it actually look? How hard is it to print? What are the, I'm just looking at my print tab. What are the different changes? Many people recommend using Dimafix to like an adhesive for the build plate. That's definitely helpful. For me, I found that unless it's a very complex print, you can. I've been bypassing it. I'm not sure it's ideal. It's kind of like in between. You have to know a little bit more of your prints before you decide to use it or not use it. But yeah, I like not using it. It simplifies it a little bit, but for some prints you definitely need to have the Dimafix. Let's see. Okay, chamber is all heat up. Now the extruder is heating up, going from from room temperature to 240 degrees Celsius. And I'm going to be looking at the questions now. What's the workflow I can expect when working with metal filament? All right, so that's a little bit covered on the website. I think it might be a good idea to also show you guys that page while we wait for the print to be done. But essentially, you're going to be printing your parts. After that, you're going to be sending those parts to be sintered and debinded. That takes place in a second facility. I mean, unless you have a sintering oven, which is, a couple of tens of thousands of dollars, I think like 50,000 for the entry-level ones. You will want to send it to a service bureau. That's covered by one of our resellers, Matter Hackers. So you just send the part back to them, what we call the green part. Let me show my web view. Here we go. So you print that green part. So essentially that part is this kind of brown-green looking part. Oh, it started. So I'll let it run there too. You're printing the green part. Let me raise the camera view a little bit so that you can actually see the first layers. Here we go. A little bit lower. Sorry about that shakiness, but just me managing this tripod. All right, there you go. So that's printing, right? You can see like printing the first couple of layers. I am printing a part called S hook. It's essentially, as the name suggests, a hook in the shape of an S. I have the part right here. I'll keep jumping back and forth between these views, right? But as I was saying, you print the part. Once the part is printed, you'll get what we're calling the green part. This green part in turn gets sent to a post-processing facility. In this case, I was describing how MakerHacker does it. So you send it to them, and in about 5 business days, you get your part back, completely sintered, and essentially it's now a solid metal part. And that's about it. I mean, we had a few comments on, well, you know, it sounds super complex, sending it out, sending it in. So definitely there's a few added steps. You are not getting the, you know, finished part out of the printer. And that's important to note, because in order to print with stainless steel, you need to have a binding agent, right? What essentially enables us to run the material through the extruder. And in doing so, you add another step of the process, which is essentially debinding that binding agent. So they, you know, in their facility, MakerHackers are essentially going to heat up the part to about 1800 degrees Celsius. And in doing that, they basically remove the binding agent, and all that you're left with is a solid metal part. So yeah, I mean, for me, it's really straightforward, especially considering the results that you get, right? I have some of the parts here. I always like to do the clanking thing, but these parts are 100% metal solid parts, right? They are magnetic, they are conductive, they are solid, they are super dense, they are stainless steel, right? It's 316L, fairly common spec for stainless steel. So yeah, it's way simpler than either machining or you know, laser cutting. I don't know which process you might be looking into, but if you're looking to create fairly complex parts that fit within this envelope, I think it's a great alternative. So once again, I'll go back to the printing view in just a second, but 3 steps to print: sinter, and get your part. If you want to learn more, you can go to makerbot.com/metals, and yeah, you'll see this page and you will be able to follow the steps kind of step by step. Let's see, next question. Does it print with a raft or purely on the bed? Yeah, no, you shouldn't print with a raft, because anything, well, you shouldn't use a raft nor supports. Anything that you print with metal, the supports, the raft that gets sent out to MakerHackers is going to be, or to become, solid metal, right? So once you sinter that raft, it'll essentially become solid and fused with the parts. So yeah, you should just print directly on the bed. And that's interesting, right? Because there's a lot of printers that are using the heated beds to, you know, kind of give you better addition, I guess. But I think that overall, in my experience, it's just so much better and easier to use the heated chamber instead. And you get the same, if not better, results. What design guidelines should I expect to keep in mind for metal parts? Okay, first off, it's going to be a smaller build envelope. You will have to work with about 100 by 100 millimeters square by, it should be about 100 millimeters, so about, you know, close to 100 millimeters cubed. Kind of this part, this is kind of the biggest part that I printed so far. Let me toggle my camera view. So printing process is still running here, right? But yeah, this is kind of the largest part that I printed so far. The reason for that is that the sintering oven has a limit of about 100 millimeters squared for those parts. Anything bigger is not going to fit the oven. So that's where the limit comes from. And second, you know, that's overall build volume. It's a little bit smaller than Method's envelope, but still, you know, pretty reasonable. Like, you know, you can see this gear. I got some interesting parts that I printed so far that are not sintered yet, right? So these two are still green parts that I need to send out to be sintered. Next up, you will need to consider that you're not using neither supports nor raft, right? You will need to either design your own supports or trust that any supports will be actually able to hold their own weight once they run through the sintering process. What does that mean? Again, anything that gets sent out to MakerHackers, if it successfully completes the sintering and debinding process, then it will become a solid part, right? So you can imagine, sometimes removing supports can be hard. Imagine removing solid metal supports, it's even harder. So most parts that I printed so far, I haven't used any supports. Even without using supports, you can create very complex geometries, right? So like kind of this gripper that I've been using here with that textured element here. So no supports doesn't necessarily equate simpler parts, but it's just definitely something to keep in mind. So no supports, build envelope, and the design considerations are, because of those two like initial statements, you will probably end up having parts that are fairly flat on one end, right? So you will want to print parts against that largest build plane. I wouldn't want to print this element like so. In this case, it sounds kind of obvious, but the idea is that the more this is a better example actually. The more stable you print your part, against the build plate, the better it will be for both sintering and debinding. So for instance, I could have potentially printed this part like so against the build plate. Let me fade here. Like so against the build plate. Let's say, imagine for a second that this was not an overhang. However, it's just so much better to print with the largest plane against the build plate. That's going to guarantee better results during the debinding and sintering process. Fading back here just to follow up on the process right now. So you can see we are at about 30% of the print process complete. And yeah, I mean, there's, that's kind of it. Let me see if the macro lens helps give us a little bit better focus here. Not really. It focuses too much on the foreground. So yeah, I think it's, once you get the lapse extruder set in, that's all you need to know, and that's all you need to do. You saw like the slicing process taken care by our cloud slicer. So pretty straightforward. I'll continue with the questions. Does the grain part already have some mechanical strength? The answer is yes, but you shouldn't use it that way, right? I've been playing around with some of these parts. You can see, for example, let's see, what view do you have? Here we go. This part is fairly sturdy already. It's really dense. I would say it's probably sturdier than my average nylon or ABS part, but you definitely want to run it through the sintering process. That's what guarantees, that ultimate part performance. That's what guarantees that these parts are essentially solid metal now. So yes, they are already pretty strong. I'm going to run a test later on. I don't have the time right now, but I'm going to run a test of, green part versus sinter part just for fun. But it's definitely a different result, and in order to have the full properties of the material, you need to run those parts through the sintering process. So hoping that answers the question. Given that X and Y axis shrinkage is less than the Z axis, what has been your experience for dimensional compliance where a shape spans all three axes? For example, maintaining a circular dimension at 45 degrees to X and Y, plane. Okay, I see what you mean. So question is, what happens when you have elements that are not necessarily oriented perpendicular to that X and Y build plate, right? Like what, let's say that, let me jump back here to this view. Let's say that instead of just having a straight circle coming back up, I had something tilted a little bit. And the answer is that, where is my part? Here we go. I have another part here like this two-way pipe. It's already sintered. So, and you can see, a little bit of that deformation happening. If I put, I'll use my phone, might be like the flattest thing that I have here. You can see how the legs are a little bit flaring outwards, from each other. So it really depends a lot on your part. Overall, for me, doing that 20% in X, 20% in Y, and 26%-ish in Z has given me the best results and consistent results to work with. It depends a lot on the part. Like if you have elements that are oriented across multiple planes and not necessarily parallel to the X and Y plane, then I guess my recommendation would be to test it out and or to test it out in a scaled part, right? So you can always print half the size of the part, see how the shrinkage is going to work or not, and then make those changes to the bigger part. But overall, it's fairly consistent. The deviation of the tolerances do increase a little bit on the metal parts. So if you start with a deviation of 20 microns, maybe at the end of the sintering process you will have twice that, maybe. It's fairly good, but it's definitely something that you will need to test, and it's heavily related to the shape of the part. So I'm sorry I don't have like a direct answer on that. Let's see. Can you recommend any software to help in the design process for metal printing so that challenges like overhangs can be addressed before entering the 3-step process? There's a few, and actually we got a recommendation from Matter Hackers themselves. I'll post it on the comment section later on. I don't have the name right now, but essentially it runs your part through a topological analysis, and that in turn gives you an idea of what are the parts that need to be covered with supports or overhangs. I don't have the name on it, but I'll come back to you on that one. After 3D printing, do you have to do an additional machining process to achieve any surface finish requirement? Yes. I would say the printed parts that come out of the machine are fairly soft, not weak, but soft. So I could say if you sand them some, it's going to be more effective to sand them prior to printing as opposed to after printing as opposed to after debinding and sintering, because it's just a softer material. If you have any surface requirements, it all depends. If we're talking about high polish, you need to do it after the fact, right? You need to do it after it's been sintered, and then you can definitely sand it and polish. So it depends on what finishes you're looking for. I would recommend, like, for the sort of more coarse finishes, do it prior to debinding. For the more fine finishes, you will 100% need to do it after the sintering and debinding process has been taking place. Can you share other properties like modulus of elasticity, modulus of rupture, and yield strength? I would recommend actually going to our page and looking at the data sheet. I'm opening it here. Oh, it's not here. So we need to update that data sheet to actually have the different strength requirements. That's a good question. I don't have the specific answer right now, so I don't want to make them up for you. But we'll update that data sheet to actually show the different technical properties. How do you account? Let me see. What are you guys seeing? Oh, cool. Yeah, printing process. So halfway done. 6 minutes remaining. Woo. How do you account for the shrinkage factor when designing? Is there a formula for producing a perfect match? There is not a formula for producing a perfect match. What I have done so far is I design my part, and then on MakerBot Print, I'll adjust those changes, or I'll make those scale changes, meaning scaling it 20% in X, 20% in Y, and 26% in Z. And so far, that's been working really well for me. The parts deviate at most about 300, maybe 400 microns, if that, but it's not that much, right? So following those 20, 20, and 26 for me has worked really well. But yeah, there will be some deviation. You're essentially reheating a part, and that will, make the part flex a little bit. Does Method have a modular head setup, interchangeable extruders? If a potential cloud occurs with a material extrusion during printing with UltraFuse 316L, what would be the resolution? So yes, the answer is all these tool heads are actually modular. You can swap them out, and essentially covers what you're describing. If I wanted, like I have a few extruders here, so if one of my extruders fail, I can either just swap the nozzle, or if the whole system is compromised, I can just change the whole extruder and keep going. The extruders start at around $250. So instead of damaging the whole print, you're just compromising the extruder. If that, most cases, at least so far, what I've encountered, you just need to replace the nozzle, and the nozzle with the labs extruder, there's 2 nozzles included. So yeah, there's no real cost for the first issue that you might have. Having said that, even when printing material, metals, carbon fiber, polycarbonates, I really haven't had issues with it. The important thing to keep in mind is that it's best not to be toggling between materials in the same extruder. What I mean by that is I have a dedicated labs extruder for carbon-related materials. I have a dedicated labs extruder for metals, and so on. Right? That essentially allows me to have more confidence in that I'm not mixing materials inside of the extruder, and in turn not causing any clogs. Will the part have internal stress due to sintering shrinkage? Yes. So that's why you need to use about solid infill, so about 100% infill. It's actually 95 the way that it works now. But during the sintering process, you will have some stresses build up, and well, that's just part of the process. The same or similar anisotropic properties like what you would expect in printed parts still exist. It's still a metal part. Sorry, it's still a 3D printed part. So yeah, it all depends on the part. Again, it's kind of an annoying answer. It depends on the part, but it's the reality of it. Will it be available in Germany? I think so. So the labs extruder is available globally. That's all you need. If you have, and I'm pretty sure that there's a reseller for BASF in Germany. Is it? I think BASF is a German company, is it not? But in any case, yeah, if you find a reseller to send you the filament, that's all you need. Both Method and the labs extruder are available globally, and that of course includes Germany. So yeah. I don't know if you guys have any more questions. We are about 2 minutes out, and it's looking pretty good, right? It's that S-hook, like so far it's been fairly straightforward. Print, I will complete the print just because we promised that we would, to show you how that print comes out. But as you can see, it's just slicing it, hitting print, and that's about it. Let's see, are there any other questions? Otherwise, I'll also be covering some of the elements in our website once again. All right, so method. All of the method models can print metal. That includes the regular method, Method X, method. All of the carbon fiber editions, they will print metal. All that you need in order to print metal is actually the printer, the Labs Gen 2 extruder, and the material, right? These two are covered by MakerBot, the BASF Ultrafuse 316L. There's multiple resellers. We have been using Matter Hackers. It's an amazing reseller. It's really straightforward. That's what I've been using so far, and yeah, really happy with it. So with the results so far. Printing process, as I said before, 3 main elements: print, debinding and sintering, and then receiving your solid part, right? So essentially, the first one is taken care by the printer. Second one by the post-processing facility, and the third one is just you actually enjoying the part and the solid metal part. Yeah, and finally, some stats for the material itself. It goes all the way to 550 degrees Celsius in the temperature resistance. The tensile strength is crazy, like 560. Megapascals and a hardness of 128. So it's in a completely different scale than our traditional plastic materials, right? That being said, there's always an application and a purpose for the different materials. So it all depends on what you're trying to do. But I think that the biggest asset that you get when printing with Method is the fact that you can easily jump back and forth between all of these amazing materials. As I said before, still my favorite by far is the nylon 12 carbon fiber, just because it's so easy to use. You get so good results and such sturdy parts. I love it. But the fact that I can also add now a few metallic elements to my components really opens an additional, a whole new league of opportunities that I can use with the printer. So that's kind of the point for me. It's just you're not buying into a closed system that will just sort of set you for either carbon fiber or metal or just ABS, right? You're having the opportunity of using a platform that covers multiple materials at once. So yeah, really excited for that. Part is finishing up. I think I'm going to give it a few more minutes. Let's see, jumping back, making sure that we cover all of the live questions. Do you have to dry the material, the metal material? No, you don't have to do it, but you definitely need to keep it dry, meaning always keep it on the Mylar bag that it comes in, or buy one of the, Polymaker sells these drying boxes. I've seen people use just regular massive Tupperwares. Either one works. The point is just keep the material dry, but you don't have to dry it prior to printing. How much wear on the print heads does this material create? So far, it's been pretty good, right? So let me show you my extruder here. Where is it? Here we go. The Labs extruder actually uses a stainless steel nozzle, and the nozzle is really, really long. The nozzle goes all the way from the tip of the extruder to about 1/3 of the extruder here, the extruder body itself. And so far I haven't seen any wear. The whole point of the Labs extruder is actually to be able to withstand that type of wear. We changed several elements in the hardware inside of the extruder, including the detection switch. Some of the gears here are also changed. They used to be nylon, now they are steel. So all of those little changes will make a difference and will extend the durability of the life of your extruder, right? So far, the extruder just takes it like a champ. So yeah. There's another question right here. Weldability of the 316L material. It is stainless steel, so you can weld it as if it was stainless steel. That's my straight answer. The fact that it's a solid material will make it behave like solid steel parts. So if you can weld 316L type of stainless steel, you'll be able to weld these parts. I haven't tried it myself, but the material is essentially that. Chemically, there's no difference between a chunk of 316 or a plate of 316L and 3D printed 316L after it's been sintered and debinded. Okay, looking for a few more questions. So yeah, I'm going to let the printer run. I think it says 86%. I think I should have scaled the part just a little bit. Because as I said, I wanted it to complete the printing process. But let's see, what other questions have we had on metal so far? You can use it on the regular method. The types of parts that you get are, essentially amazing. I have a few. Let me switch my views here for a second. Whether you want to try different textures with the material, these are the parts that I will be showing are still all green parts that I just printed out, right? So really nice finishes on the parts themselves, and that's one of the key things to keep in mind. It's sort of like that garbage in, garbage out, meaning if you don't have a printer that delivers consistent results, you will have issues with the material, right? So it's true that this material can be used with other platforms. We've seen other desktop printers offer it as well. But the fact that with Method, you just get that much better, resolution, accuracy, makes you start with a much more solid, solid state of affairs. When prior to sintering, prior to debinding, these parts are already really, really, really accurate. So since they are already really accurate, like going back to that conversation around the scaling and warping issues during the debinding and sintering process, the fact that you're starting with a part that's already really straightforward, really close to spec, allows you to have better results after the sintering process has been completed, right? As I said before, with all of the parts that I measured, it's not more than 100, 200 microns deviation at most. So really, really great and consistent results, I would say. Let's see, where are we now? 93%. Should be a few more minutes. You can see the part. Let me tilt this a little bit to give you that extra view. Yeah, I mean, you can see that I'm printing a completely solid part. It's also, it's not using any Raft. The part itself, it's a little bit bigger than this S that I have here in my hand, but that's what I'm printing. I'm printing an S hook, and the reason for that is that I will be doing tensile strength test later on. I have my rig, if you can see it behind me, here we go, my rig behind me. So I'll be doing some tensile testing later on, And just to see, you know, we had a few questions around, you know, how does the green part strength compare to, you know, other plastics? You shouldn't use the green part as a done part, because it's essentially, it's not metal and it's not a polymer, so it's just a state in between. But I think it's an interesting thing to see, you know, how does it compare a green part versus a sintered part versus a plastic part. So we'll be doing that test up next. And let's see, are there any other questions? Porosity, resistance to water under pressure for the material itself. I am not sure I have a specific spec for that. This is a solid part. It's about 95% solid. I would need to make the calculation, like basically, you know, check that density versus the volume and the weight that I get. It's fairly solid parts. I have no direct answer to the resistance of to water under pressure. Would it be appropriate for low volume automotive production? How does the final part cost compare to metal in the injection or molding? Oh, it's finishing. I'll come to that question in just a second. It's always exciting to see the part done. But yeah, that's, let me open the chamber here so you guys can see it. That's it, you know, half an hour, got my S-hook. If I wanted to send it to sintering, that would be it. It's already done and ready. You know, really straightforward process. So I'll just take one more question, the one that I was about to answer, and then, you know, cover it up. But if you have any more questions, do send them out to hello@MakerBot. We'll be sure to answer those. Would it be appropriate for low volume automotive production? How does the final part cost compare to metal injection molding or traditional casting? The answer is, it's as always, sorry, but it depends. So yes, it would 100% be a great option for low production parts. For instance, this particular part, we made the estimate, and it's about, you know, the finished part comes at about $30, maybe $40 with the post-processing and sintering process included. And that's as it's part of a batch, of a larger batch, right? Because every single sintering ticket will cover 1 kilogram of material. So, you know, this part is about 60 grams. You can probably send 15, 18 of them out for sintering for about $50. So that splits the cost amongst all of them. And then, you know, yes, I think it would be great for low production. And now, compared to metal injection molding or traditional casting, the main difference is going to be the possibilities that you have, right? If you want to print something a little bit more complex, you can see the texture that I got on this part. That's something that you would never, I think it would be really hard for you to get from a casted part. You know, let me change my screen here. It's going to be really hard for you to get that resolution, that level of detail, that complexity on casting. Also in injection molding metal, it's just not going to be that straightforward of a mold, right? With 3D printing, you don't have to rely on the mold, so that's the value of it. But yeah, I think that with that, we covered most of it. So again, thank you guys so much for joining us today. If you have any questions, don't hesitate to reach at hello@MakerBot or Felipe@MakerBot.com, also in social media, at MakerBot, either on Twitter or Instagram. And yeah, we'll talk again next time. But thank you.